Power. When we deal with electricity and electrical current, we also can discuss power. How much power is that circuit using? How much power is it being produced? Power is a capital P, and it is equal to current times voltage. Or, since we know voltage is equal to current times resistance, we can do a substitution for V into that equation, and we can also say power is equal to I times R, which is I squared times resistance. So power can be found two different ways. Power is equal to current times voltage. It is also equal to current squared times resistance, and that's the total resistance of the circuit. The unit for power, it does have units just like everything else. The unit is a watt. And 1 watt is equal to 1 joule of energy per second. Okay? So if you have a 60 watt light bulb in your house, basically it's running 60 joules of energy per second through that line. So now we are going to look at a couple circuits to see how much power is each circuit pulling. So the first one is a simple series circuit. We need to find, we're wanting power. What do we know? We know voltage is 12 volts. We know we have 3 resistors in series. So they're in series, so it's straight adding them up. 2 plus 4 plus 4, which is 8 plus 2 is 10. So we have a 10 ohm resistor. So what do we know? We know voltage is equal to current times resistance. We know 12 is equal to current times some number 10. Some number times 10. So that means current is equal to 12 divided by 10. So we have 1.2 amps of current running through that system. So power is either IV, it is the same thing as I squared R. I'm going to use IV since we know V and we know I. So that is 1.2 times 12, which is 14.4 watts, or 14.4 joules per second. Well, will we get the same? Should we get the same number if we do the I squared times R? It depends on how you round, but you should get very close to that number. So let's check. If we use the I squared, we know it's 1.2 squared times R, which is 10. So 1.2 squared is 1.44 times 10. So 1.44 times 10 is 14.4. Oh, look, same number. Yay, we did it right. So let's look at another circuit. Now we have this circuit. Well, what do we know? We have a 3 ohm resistor in parallel with a 2 ohm resistor and a 2 ohm resistor. We know voltage is 12 volts. We don't know current, so we can't find the power that the circuit is supplying, but we can find current. So we know it's a parallel circuit, so that's 1 over RT, which is equal to 1 over resistor 1, which is 3, plus 1 over resistor 2, plus 1 over resistor 2. So 1 over RT has to equal 0.33 plus 0.5 plus 0.5. So 1 over RT is equal to 1.33. So now we flip. So we get RT is equal to 1 divided by 1.33, which is 0.75 ohms. So we have that. So these three resistors equals 0.75 ohms. Now we need to find our voltage. We know voltage is equal to current times resistance total. So that's 12 volts is equal to current times 0.75. So current is equal to 12 divided by 0.75, which is, so that is equal to 16 amps. So we now know our current. So we can find power. Power is equal to current times voltage. So that's 16 times 12, which is 192 watts. So that's how you find power per parallel circuit and a series circuit. Okay, we use power. The electric company charges us for that power that we use, and they charge per kilowatt hour. So let's say we have a light bulb on, and it's a 60-watt light bulb. So we know power is 60 watts. Okay. Well, we decide to leave it on for 24 hours. That's the time that it's ran. Okay. And let's say the electric company charges us 0.08 cents, basically 8 cents per kilowatt hours. So how much does running that light bulb 24 hours really cost you? So we know we have a light bulb that's 60 watts, runs for 24 hours. So power times time is the energy used. And that is equal to 60 times 24. Okay. And that will get you in watts per hour. So what is 60 times 24? We know we've used 1.44 kilowatt hours of electricity at 8 cents per hour. So we now know that 1.44 times 0.08 is about 12 cents. It's 0.115. So rounding to run that 60-watt light bulb all day is 12 cents. So when your mom's yelling at you to turn the light off, you can show her that you are not using that much money in the terms of electrical usage in the house. What do you think uses the most electricity in your house?